Alright, so for this reassessment, we're going to be looking at collisions. The problem states a ping pong ball and a bowling ball collide elastically on a frictionless surface. The magnitude of the initial velocity of the ping pong ball is v of p of 0, which 0, I'm guessing, can be the same as saying the initial velocity. So as the problem continues on, it says the ping pong ball is v of p of 0 and the direction of the velocity is in the positive x direction. The magnitude of the initial velocity of the bowling ball is v of b of 0 and the direction of the velocity is in the negative x direction. It says that we may assume that the mass of the bowling ball is much greater than the mass of the ping pong ball. We are asked after the collision, what is the velocity of the ping pong ball? So kind of simple problem, not a lot of numbers or anything, but it's just a guide to help us figure out how to set up a problem that relates with collisions. So as you can see down below, I start off with a free body diagram which states that our ping pong ball is going in the positive x direction, and then our bowling ball is going to be going in the negative x direction, and we're asked to find the velocity of the ping pong ball after the two of them collide. So the first step that we're going to have to do is we're going to have to find the initial relative velocity. So from that, we know that our velocity of the ping pong ball in the positive x direction minus the velocity of the bowling ball in the positive x direction equals our initial velocity of our ping pong ball minus our initial velocity of the bowling ball, which gives us an equation of our initial velocity of the ping pong ball plus our initial velocity of our bowling ball times our I hat. So this is the equation for our initial velocity, which we're going to use later down below. But in order to solve for the collision of the ping pong ball, we also need to find our final relative velocity. So in order to do this, we know that our velocity of the ping pong ball in the positive x direction minus the velocity of the bowling ball in the positive x direction equals our velocity final of our ping pong ball times negative I hat minus the velocity of the bowling ball times negative I hat. So when we do this equation, we're going to get a negative velocity for the ping pong ball plus a positive velocity for the bowling ball due to the fact that our two I hats, these two negative I hats right here, are going to cancel out and give us a positive number. So therefore, we can determine that our velocity, our initial velocity is equal to our negative relative velocity final. So our new equation can be written as v of p, which is our initial velocity, plus v of b of our initial velocity times I hat equals negative v of p initial plus v of b initial times our I hat. So our final speed of the ping pong ball is going to be v of p final equals v of p, which is our initial velocity of our ping pong ball, plus 2 times the initial velocity of the bowling ball. And if we implement all these equations, we're therefore going to get this equation down here, and if we plug this in with numbers, this is how we would set it up, and we would get our final speed of the ping pong ball. So therefore, that's pretty much all relatively the equations that have to be set up step by step in order to solve for the final collision of the ping pong ball. So thank you.